So this talk is how faster than light speed observations in astronomy are ignored. The first thing to note is the letter C. It means light speed in vacuum, and by vacuum it means there's no effects on it, such as from gravity, and you're treating outer space as a vacuum, although it's not a perfect vacuum. So what it is there's no restriction on the speed of objects in Newtonian physics, but what's happened is the correspondence principle has been falsely stated by the mainstream. The correspondence principle is how Newtonian and Einsteinian physics are connected, and you need to see my other video on that called Development of Einsteinian Physics from Newtonian Physics. And the correct treatment of Newtonian physics is it has no restriction placed on it by light speed c, and mainstream articles have been falsely placing that restriction on it. So this is a reminder of the relevant paper which was dealt with by the video. And it's the problem with time in the Lorentz transformation. I'm just going to assume you are familiar with these equations. You have the Lorentz transformation, that's the first equation there, and the Galilean transformation for time is the one below that. So starting from the Lorentz transformation for time, you take v as a low speed, and what is the gamma factor approximately then equals 1, and then that equation for Lorentz transformation for time approximately equals that equation t minus vx divided by c squared. And the trick being used was to think that v tends to 0 when vx divided by c squared tends to 0, but that's not what happens, because as v tends to 0 can make the x term arbitrarily large, so that means there's no reduction of Lorentz transformations to Galilean transformations, meaning that the claim that Lorentz transformation produced Galilean transformations at low speeds as being a good approximation is a false claim. But based on the false correspondence principle, the mainstream then restricts Newtonian physics to be less than the light speed c, and doesn't allow Newtonian physics to have speeds greater than c. Thus we have two versions of Newtonian physics. You've got the version where Newtonian physics is forcibly restricted by the speed c, and the other one, the correct version of Newtonian physics, where it's not restricted by the speed c. And mainstream have based their belief on the first one, where they're going to be speeds restricted by light speed c, and they're going to ignore astronomical observations of speed greater than c, and that's abbreviated as FTL, faster than light. So what we're talking about here really is in the context of treating space as not expanding, and that's meaning treating it as approximately, not expanding as a good approximation. The expansion of space was dealt with in my previous video, misconceptions of Big Bang. So now the relevant paper is this one. It's the paper title says, to set the record straight, nothing can break the speed of light. And by that they mean the speed c. So the article goes on to say, back in 2018, astronomers examining the ruins of two collided neutron stars in Hubble Space Telescope image noticed something peculiar: a stream of bright high energy ions jetting away from the merger in Earth's direction at 7 times the speed of light. That didn't seem right, so the team recalculated with observations from different radio telescopes. In those observations, the stream was flying past at only 4 times the speed of light. So what we got really here is FTL has been observed. FTL faster than light. And next, what they're going to do is come up with a method to ignore that observation. The article then goes on to say that didn't seem right. Nothing in the universe can go faster than the speed of light. I.e. the article is stating its belief that nothing can go faster than the light speed c. And I'm minding again, this is in the context of space, that is not expanding, and the article really doesn't go into explain that properly. But if you need to see my other video, Misconceptions of the Big Bang, in the context we're dealing with, we're treating space as not expanding. The article says the following: as it happens, it was an illusion. A study published in the journal Nature explained earlier this month, i.e. FTL, faster than light, is observed, and that is contrary to belief, so it's dismissed as an illusion. So getting on to a relevant bit in the article, it gives the following explanation. And this is a person saying this, so it's in quotes. They look like they're moving across the sky crazy fast, but it's just that they're moving toward you and across the sky at the same time. And that's said by J. Anderson, and he's talking about the ions. And my comment on that is, in Newtonian context, what is being talked about is the resultant speed. So let's draw a triangle for that. This is the triangle of the resultant speed. R is the resultant speed. V subscript W, the speed moving towards you, and V subscript B, the speed moving across the sky. So then R is the resultant speed. In this case, you've got the resultant speed greater than the c, and it's not an illusion. According to this triangle, speeds are being vector added together, and they're greater than c. I've got arrows on these speeds, but don't really need to bother about that. So what we have is a flawed thinking of the relativists. They don't want speeds greater than c. So when have a speed greater than c, they're just going to call it an illusion. What it really is the Newtonian vector addition of speeds, giving resultant speed r greater than c. But because they believe in the false correspondence principle, they're not going to recognize that is what they have. We now can contrast that with what has happened in the history of physics astronomy. So this is Galileo. The first time a telescope was used in astronomy, what I'm aware of. So what Galileo saw conflicted with the existing beliefs of his time. So how did the mainstream of his day respond to that? The answer to that is they dismissed his observations as illusions. I got this quote from Wikipedia saying about that, but really the issue was more complicated than that. People who looked in his telescope found it hurt their eyes and so gave up looking. But the general point is what Galileo observed was dismissed as illusion. And the same happens today now with astronomy as it did in Galileo's day. Observations of faster than light FTL are contrary to beliefs, so are dismissed as illusions. We might think we are cleverer now than the people in Galileo's day, but what unfortunately happens is we're still carrying on doing the same old thing. When something doesn't agree with what our beliefs are, the tendency is to ignore that. In the case of this one, FTL, faster than light, observations are made and they're being dismissed as illusions because it's contrary to what they want to believe. Finished, thank you. This is the end of this little talk.